But now the interest has grown. The interest has grown on a national level, so there's a lot of funding money from lots of German ministries. It has grown on a European level, and I will also mention that later. And it has grown in industry. So industry somehow thinks, no, well, it might make sense to share some data. Also driven, of course, by the rise of artificial intelligence that somehow promises that if you have a lot of data, you can find some insights. Whether that's true or not, we'll see. Okay, so why share data? Question is as old as Shakespeare, you see. So within organizations, we heard this morning, well, you have shared knowledge, you have a single source of truth, hopefully. You have you have more efficient processes if you know what the other the other departments are doing. Or, for example, the order-to-cash process. You can do AI training, you can do benchmarking, whatever. So within organizations, there's a lot of reasons to share data. How about among organizations? Well, shared knowledge, yes, is also a reason. But you don't want to share all your knowledge, probably. We are talking about digital twins, distributed digital twins that live as long as a product lives. So it has to travel somehow with the product, and it has to be enhanced by data from many, many organizations, from the producer to the delivery, to the consumer, to the recycling. So that also is a reason for data sharing. Of course, more efficient processes along the value chain. I'll show an example later. Also for AI training, and very important use case these days for circular economy, because you can better reuse or recycle or reshape a product if you know what's in it, so you need data sharing. But there are also reasons not to share data. Within organizations where you might have heard of competition among departments, and of course knowledge is power, as we say in Germany, Wissen ist Macht. Because of the complexity, and you heard a lot about that this morning, and because of the need-to-know principle, which is inherent in organizations as well. But there are even more reasons not to share data among organizations. The first of all that comes into mind for every industry probably is the competition, because if you share, or you happen to share unwillingly your business secrets, that might hurt your business very much. And there is more business secrets than you might think. So even if you just share the performance of the machine, some clever engineer on the other side may derive how your order volume is, and whether you are in good shape as a company or not, whether you have still free resources or not, and might adapt his pricing model to that. So that's not it. You don't want to share. It's, of course, as well complex. There are legal restrictions, I will mention them in the end. Of course, lack of trust. What will the other company do with my data, my precious data? Will they misuse them? And of course, if you share data, once shared, they're shared forever. You cannot just revoke them. I mean, that has been discussed, but there is no real technical solution to revoke data. So, as I said, I'm talking about data sharing among organizations here, and as mentioned before, one-to-one sharing, that's an old story. And now we're talking about sharing in all directions between multiple players, and call that data spaces. That's even done in science nowadays. You might have heard about the NFDI, which is a German initiative to share data within a discipline. Nationale Forschungsdateninfrastruktur. There are a lot of consortia in Germany, I think about 30 in various disciplines, who try to set up some data sharing, and even in science there are well, resentiments to share, or maybe more in science than in industry, I don't know. And on the European level, the European open source, no, what is it? I forgot it. It's European Cloud Science, Open Science, right, thank you. European Open Science Cloud, yeah. That's more or less an FDI driven to the level of Europe. And there are well-known examples from industry, well-known because the German government has put a lot of money in it. Catena-X, which is data sharing among the participants of the automotive value chain, so the large automotive companies from Germany all participate in Catena-X, and Manufacturing-X is more or less the same for the manufacturing industry outside of the automotive industry. And both of them get a lot of funding from the industries. Okay, so now what is a data space? And if you read all that, I mean, you don't, I will not read it to you, and it's just that you get an impression. There is a lot of buzzwords around data spaces, but not a real definition. So everyone talks about it, but what it really is, no one wants to be very clear, yeah, and says this is data space and this is not a data space, which you would expect from a real definition. Maybe the best one that I found, which is also not perfect, is this one found in a source edited by the German Ministry of Economics. And it says it's a federated, it's open infrastructure for sovereign company data exchange based on rules. Well, not very surprising. You probably would have expected that. And if you look at the definition on the left-hand side, the word data, I mean, the existence of data as a prerequisite for a data space is not even mentioned, which I find interesting. It's mentioned in the first one, so I somehow color-coded this sources of information. It's the only part of this definition which really mentions somehow that information. It's not just infrastructure, it's also data. Good. Going ahead to that, why would you do that? And for industry at least, and I think it's the same for science, you would not build a data space without any value proposition that gives a value to every participant of the data space. And I will give you some examples, all coming from projects that we are currently doing. I already mentioned Catena-X Manufacturing, so I will not show them here, but I will show some examples from various industries, various sectors. So the first one is maybe an unexpected one. It's a data space for the construction industry. So if you're building a house, about 30% of the whole time that it takes to build a house is waiting time. Worker 1 waits for worker 2. So the painter waits for the, the window installer, and so on. 30%, which is incredibly much, in particular in large office buildings. So if they knew about each other and when will the one be ready and when will the other come and so on, that could create a lot of improvements in the construction industry, and that's exactly what we are doing in this project. The particular point here is that most of them are small companies. So they don't have large IT, they don't have IT people. I mean, they operate machines like that, and not computers. So that's a challenge here, and we somehow want to overcome that. And this is the only I think the only architecture slide I have, because I want to show just one point. Let's see whether No, that was the wrong button. This, no, there's no. There's a pointer. It doesn't work. Oh, it doesn't matter. This one. This one is the data sharing infrastructure. Maybe you don't know the IOTA tangle. It's a distributed ledger. So in this case here, the architects have decided to do all the data sharing via this distributed ledger, which, as you know, is probably not the most efficient way to share data, but it has some advantages. Okay, next example is from rescue operations in the context of automobile driving. So AMS stands for automated cars, and one use case here is that when rescue, the fire brigade, for example, wants to get to an accident on the road, they broadcast this information via the data space, and then all the cars, the automatic driving cars, by themselves will form in German it's a Rettungskasse, so they form a lane where the fire brigade can pass through. And the other cars, which are still operated by drivers, they get a warning somehow that they have to form this rescue lane. That's a nice, by the way, if you look that up on the homepage of that, there's a nice video showing the simulation of that. And they're also doing real field tests, so that's really nice to see. Okay, next one, and now I'm talking really about industry, or about the industry that you might have in mind when you say industry. This one is for the machine construction industry, and you see the departments down there. One use case here, I find it quite illustrating, is one of them produces a cylinder, and the other one produces a part where this cylinder fits in. Now they're talking about tolerances, because in these industries you have to have small tolerances. If you have the distance between the outer wall of the cylinder and the inner wall of the fitting box must be very small. But when you produce that cylinder, you have tolerances that might be too large, such that not every cylinder fits in the box. But if you could match them, I mean, the box also has tolerances. So if you put a cylinder that's a little bit too big to a box that's a little bit too wide, then you can save waste, and you can be more efficient in using your resources. Next example, this is more or less a child of manufacturing X. This is the project that we've seen before, brought to the next level, more or less. So it's also about the production industry. And final one that I will show here is DS2 or DS squared, because this wants to connect data spaces to each other. Now, we might ask, well, a data space is a federated thing. And a federation of federation, do you need this level, do you need this hierarchy, or could you just extend the federation that's there anyway? And the reason for this research is that not all data spaces use the same infrastructure. So, although one data space might allow everyone to share, every participant to share data with the others, it might not be compatible to the other data space, which of course is a problem, but that's how the world is. And then you need some bridge between them. And I'm quite interested what comes out here, because this bridging creates some interesting questions. Okay, now I've shown you a lot of examples for data space, motivating why there is some business value in data space. But there is a lot of open questions that you might ask now, or you should ask now. What about the infrastructure? Every data space has to implement its own. Is that really a good idea? Maybe not. So how can we ensure that these infrastructures are compatible to each other? Can we somehow ensure interoperability between data spaces? A question that's also to be answered for this NFDI and EOS things. Can we reuse the infrastructure that has been built for one data space for another data space? Well, being a computer scientist, of course you would say, yes, 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 you must do that. Yeah, but reality is different. And what about the semantics of data? I mean, I talked a lot about what you would do with that, but company A shares some data. Company B wants to consume that. But how do they know the semantics of these data? Is there a standardized way to describe the semantics? That's a question that has to be answered for every data space. And I know from this science data space, from the NFDI consortium, that they have put a lot of thoughts into that. But there is no, as far as I can see, no solution that fits all data spaces. So what about data location? I already said it's federated, so there's no copying of data. In contrast to data warehouse, you don't keep copies of the data. You just have the infrastructure that federates the data sources, and every holder of data is sovereign. And is it just data that you share? Or shouldn't you also offer data-related services? So for example, AI services. For example, services that use all the data that are somehow available within the data space to learn models, to derive some value. Wouldn't that be part of a data space as well? Now, there is an answer that has been tried by Germany. The German government, together with the French government, has set up the GaiaX initiative, and now more European countries have shared that. And it's called GaiaX because of this nice X that's depicted here. And you see there are several building blocks that should be genuine, that should be used for every data space, usable for every data space. The catalog containing the description of the data and the services, an identity and trust component, and the compliance component, and many more. And then above you see that based on the various data spaces that you could think about, smart services should be implemented also as part of the data ecosystem. So that's the goal, that's objective. Again, German and French government have given a lot of money to implement that. Unfortunately, not very successfully. So there is an implementation of reference implementation, but it's at the moment it's not stable and it's not really usable, which is a pity. Yeah, but that's life. So probably it's not a good idea if governments try to create such a structure. Nevertheless, several of the projects that I've shown before, in particular those that have X in their name, they claim to use GaiaX or to be compatible with GaiaX, whatever that means. Yeah, but they have to implement, sometimes they have to implement their own components as a replacement for the GaiaX components because these just don't work. And to make it even worse, there is a similar initiative on the European level called Simple, and the European Commission gives a lot of money to create more or less the same as GaiaX. Yes. This has been procured last year, and it should be But the first version should be available in autumn this year, which is ambitious. Being a computer scientist, you can just say it's ambitious if you have seen the catalog of requirements that they put on this infrastructure. And they also promise to create European data spaces for health, for language, and others. So if you are interested in that, there is, of course, a homepage of Simple, driven by the European Commission, and you can look it up and yeah, make up your mind yourself. Now, I've talked about some aspects of data space and I just wanted to give you an overview. I did not mention the other aspects in detail. So semantics, yeah, as I said, you have to somehow understand the kind of data that is offered. And I mean, we are not talking about name, address, and zip code. We are talking about deeply technical information. And yeah, there are, of course, standards to describe them. Unfortunately, too many standards to describe the same data, so yeah, we have to somehow find a compromise within the data space which semantics you want to use, and then you have the problem that you might be incompatible with another data space within the same domain. Scaling, well, I've shown you some projects that have been initiated by the German government and funded by the German government. But how do you make sure that all companies in that sector somehow can participate in data spaces and not just those that receive the funding? Very important question in particular for industry is there really a business model? I mean, there's a lot of promises, but does it really pay off? That has to be proven. And not to forget the legal aspects of the whole thing. There are some regulations by the European Commission. I'm not sure who of you follows the regulations that have been edited or that have been given by the European Commission in the last, let's say, 3 years. A lot of, I can tell you. Yeah. The Data Services Act, the Digital Market Act, the Data Governance Act, the Data Act, the AI Act, and. In this case, in particular important are the Data Governance Act and the Data Act. The Data Governance Act unfortunately forbids a model that has been a promising business model for data spaces. Namely that the organization that somehow cares for the data, that somehow operates the data space, they must not offer services in the data. That's forbidden by this regulation. And of course the services would be an income, a sort of income. Yeah? So how would, I mean, where would the income for this data space organization come from, if not from services? So this regulation really creates some headache for all the people involved in data spaces. Yeah, in the Data Act, it requires to share data in some interesting constellations, and it's still to be seen which influence that has on data spaces. And of course, there is also national law that has to be looked at. For example, health data, there is a national law in Germany, and there's a national law in other countries, so you cannot just share health data between the various states of the European Commission without considering all these laws. And of course, if you share your data, you want to have some contract. I mean, before you share your data with someone, you typically want to have a contract, which means that all participants in the data space somehow have to agree on a common contract, which, if you have touch points with legal persons, can take some time and some discussions. Okay, that's it. So I just wanted to give you an overview about this fuzzy world of data spaces. So you know it's not a technical invention. It's more or less a term that has become very frequently cited and quoted, and now you know about it, more or less. Thank you.
Questions?
What about the GaiaX and Silver? GaiaX is very European, at least from projects.
GaiaX is an initiative well, it started with Germany and France, and then several countries joined. But it's an initiative by the member states, not by the Commission. And if you know the political situation a little bit, European Commission is not always looking or respecting what member states are doing, and they think they can do better. And maybe they also noticed that GaiaX is not really trying. So in their papers, I mean, if you can read the papers, the requirement papers, there are several hundred pages, and they say, well, you should not implement something that has been implemented somewhere else, and they mention, among others, they mention GaiaX. What does that mean? I don't know.
More questions?
Bernhard?
But, so thank you for the nice presentation. It does give a clearer picture, yeah. But industry needs those data spaces. So what is your take on that?
Well, yes, industry believes that it needs these data spaces. But still, for every participant, there has to be a business model. There has to be a return on invest. Otherwise, I mean, industry doesn't spend money just on the gut feeling that this might be a good idea. Yeah? They want to have some perspective on the return on investment. And I cannot see that this is the case in every data space initiative now. I mean, in this construction data space that I mentioned, yeah, there should be a return on investment for every participant, because avoiding waiting time is, of course, worth some money. Yeah? So that should be a good use case, and if it really works out, that might work. Yeah? In this manufacturing example, it reduces waste, which might also be a good motivation. In this rescue thing, who will pay for that? I don't know. Maybe public money, I don't know, yeah, because it's rescue. Yeah, but you have to find such a business case for every data space. Otherwise, no one will pay.
Isn't, for example, when you have production chains or supply chains, isn't this a good background on which those associated companies could really start and think about a common data space?
Yeah, that's exactly the idea behind this containerics, which is in the automotive. I'm not sure. I mean, if you see how the companies in the automotive value chain, how they work together, it's often that the OEMs, the companies that build the cars more or less, that they force their delivery chain to give all the data and whatever without them having a real business value. So these are other forces, and it might also work, of course, and it might be technically interesting to do it this way rather than the traditional way, maybe. But I'm not sure that all the companies in the delivery chain really have value.
Yeah, okay. Thank you.
Well, maybe we should take the remaining questions to the coffee break. Thank you again. And switch quickly to the next presentation, which is about data science and AI, and given by